This is installation day. This is an exciting time. Our client, we sat down with them a number of times just going through different ideas. You know, we really wanted to design a bespoke design, something that fit their personality. There's always budget that's concerning and how much it's going to cost on the initial installation. There's a lot we can do with lighting. I always say we can do just about anything with lighting, it's just time and money. So what we did is we came up with a stepped plan. So this stage, we decided to focus on the front of the house. This is going to be the most impactful section that we do. So we're lighting the trees properly, pulling the lights further back, adding the proper lighting on the front of the house, doing some second story and third story lighting. So we're meeting with the customer. We're going to walk them through the installation. Josh is going to talk to them, go through the plans. We're then going to really get going on this installation. They have a full working plan on what we're going to do and how we're going to accomplish this as efficiently as possible, making certain we don't tear up the yard. Our goal is to make the property look better than when we got here and add beautiful lighting to it. So stay tuned to watch the entire installation as we showcase each step we're doing, and also the final reveal night so you could see the design and how it all turns out.
Upon arrival, our team likes to get right to work, and they're trenching. We're going 6 inches deep, and that keeps us below any maintenance that might be done on the yard. Aeration, that's a big problem in the spring and fall. It keeps it below that, and it's a lot of hard work early in the morning, and we like to get the hard work done before the sun gets too high.
So we always expect the unexpected on every project, and one of the things that we believe in is investing in proper equipment. So we're out on the project, we called Miss Utility. Miss Utility in Virginia marks all the lines. The one line that we're always most concerned about is FiOS. FiOS is buried typically at the least amount of depth compared to other utilities that come in. This one was marked all clear, but we don't see any orange lines. Orange lines is communication lines. So we've invested in basically the same equipment that Verizon or that Miss Utility has. So we hooked up to the copper wire and we're tracing it, because one of the worst things that can happen to our clients is while we're working, the FiOS gets cut and then they have a day or two without internet. Obviously that's always upsetting in this modern age. And the other thing is then the Verizon or whatever utility company comes, runs a new FiOS line, and then that has to come and get buried again. So we like to just take the precautions and get everything taken care of. So Josh is here testing the line. Josh, you want to talk about this?
Yeah, so it hooks up to whatever line, any copper line that you're trying to trace. And this is it senses the signal in the ground, and you take your receiver and you wave it over the ground, and it'll tell you exactly where that line is. So it's coming right through here. So we're going to mark this for the guys. Right next to that rock, right through here.
So always trust but verify. We never just blindly go in and believe that there's no utilities here. Obviously, we see Verizon has the internet, so now we just take it upon ourselves to go the extra step to make sure that it's marked and we're protected, the client's internet is protected, and we just hand dig 18 inches off of this line here. Even though it wasn't marked, it's just an extra service that we feel is important, having done this for long enough. That could ruin someone's day, and we don't want that. This is a fun experience.
Other than losing power, losing internet is about the worst thing that can happen nowadays.
So we found the existing wire. The plane goes by. We found the third wire coming around in a totally different way, but we located it. It's buried at a good depth. We're about 7 inches deep. This wire hasn't been opened or doesn't have any connections prior to this. So we're going to cut this, we're going to splice it, and then run it over towards the front. So anytime we're working on an existing system, there's always more troubles than if we're just starting brand new, but there is some cost savings. So in this case, we're just trying to figure out where the wire is coming out of the house, underneath the patio, determining that, and then from there, we'll look to see where that first connection is. So some of this wire we might be able to use. Wire typically is going to have a 25 to 50 year life underground if the connections are done correctly. So what we'll do is if we're able to use 2 or 3 of these wires and we don't need any more, we're able to cut it before that first connection, run all new wires, do proper connections on it, make sure there's no corrosion in the wire. So right now that was the one thing we are uncertain about coming into installation day, is how the wires are coming from the transformer across the patio. Something that if we had more time, we would test every single detail, but you just can't test everything before you really get into it. So that's what we're doing right now. We're just determining what the wire diagramming looks like exactly, and then building out from there. So the ground here is incredibly dry. Most of the time people put lights too close to the trees. We're pulling it back as far as we can go. If we go any further back, we're using well lights, but the ground is really hard. This is what we use to put our fixtures into the ground, or our luminaires in the ground. So what Kevin's doing here is he's making a pilot hole, and as he's pulling it out. Our fixtures have a base that is much wider, so it gives us a place to really tap it. So he's going to get that hole deep enough, put it in, and then do just a couple taps onto the stake and get that perfectly set in the ground. So our team now is at the point of starting to run some wire. This is the quick spooler that we use. We've been using it for many years. We have a solid steel bar. We use this for other things, such as putting the wire into the ground or poking into the ground. We're getting ready to lay the wire into the ground. The trench is all set at minimum 6 inches, a lot of spots. The ground was a little more wet, even though it's been real hot out lately. We did get enough rain and that it softened the ground, so we were able to get 9 inches in most spots. So we're gonna lay the wire in the ground. We're gonna then poke it into the ground to get it to the proper depth and fold everything back. Everything is surgical, so by the time we get done with the installation, you really won't be able to tell we're retrenched. So we're at one of the most important stages of the lighting installation, is the connections. This is where poor connections will cause lots of problems. It's where energy loss can happen. It's where corrosion can set in the wires. We designed our own connection system many years ago that we've been using for 15 years at least. The only 2 connections that I really recommend is a heat shrink connection, a permanent connection, or the connection we're doing with a crimp and our gel packed connector system. We use the Blazing LV 9500. Those are the 2 that I like the best. We've done soldered connections, we've done the tube connections with its smelly grease. We've done a lot of different types of connections. I don't like the wire nuts. The gel pack wire nuts tend to not hold any pressure, come loose and corrode and let moisture into it more. So Josh is going to show you this connection style we do here, how we do it, and why we designed it this way. So this is UL listed without the copper tube. We add the copper tube because it just makes a lot of sense to get that connection really tight and permanent, and then pull the connections away from each other. So Josh.
Sure.
You like those connectors, or those cutters still?
Yeah, I'm getting used to them.
Like
It's a little different how we used to do it, but
I like the old-fashioned ones.
So this is a little different than your typical splice, because you're going to strip back a little bit more of the insulation. You're going to take about 1.5 inches or so, 2 inches, about that much.
And the way this connection works, the wires come into here, the tube's going to be in the middle, and then the wire folds over. The top is filled with a grease. It fits over, and it's actually locking it in a second location. And if somebody wanted to, you could put a stress relief on it. We haven't needed it a lot the way we do our connections, but you could put zip ties or any kind of device to make it so if you come and pull the wire up, it doesn't separate. But Josh will show you how we do it.
So these connectors, if you follow the instructions, you just put them in just like that, but we like to add this crimp right here, and this is really what makes your connection solid. keep it from heating up if you have a lot of amperage on the line.
There's mechanical crimpers and different type, but that's a really strong connection. We found that was stronger than soldering it.
So with that crimp on there now, you're going to break that wire before that connection is going to come loose. So once you have that, you feed it up through the bottom part. With the copper crimp goes inside this tube, and then you fold the rest of your copper over. And these are packed with silicone. And when you pop it on there, you can see that silicone out the back. It's just completely covering that copper in there.
So we could come back, typically these connections 5-8 years later, and the copper is still shiny, looks nice.
And that's it. Nice and quick.
And when we bury them, we're typically going to pull them apart and pull the connections away from each other. So that's going to get buried typically 9 inches deep and separated apart just like that. So that's a great connection. You could also heat shrink your connections, and that's another really good connection system to use. But this is so important. If you're not doing the right connections, you could have 50 problems on a job that are just ticking time bombs. Do them right, they're permanent, they last, and you never have to worry about them. So this is Bryce Hanvey. Bryce has been working with us 6-7 years at this point. And Bryce is the lead technician running this installation. So we've already sat down, we've gone through the paperwork, we've watched the videos, he knows everything about the job, but getting on site and actually looking it all over and walking it through with him just makes certain that communication is perfect between our designer, our installation team. He's really the glue that holds everything together. So he's going to be making certain everything is done perfect. Everything's on his shoulders. He signs off on the job when it's all done and takes full responsibility, so he's on top of every aspect of this project. Then we have working documentation. We have the proposal, we also have drawings. So Bryce is really given over information on each project, and then once a week we sit down, typically on Thursday morning, and our design team, our installation leaders meet together just to make sure there's no questions on any project. And then if there's a challenging project, then the lead designer is going to come out on that. But most of the time, we're able to have great communication and just enough experience. Bryce has been doing this 6-7 years. Andy or myself, Josh, have been doing this 15, 20, 25 years. So, you know, we know what we're doing, and it's really at that point just making certain communication is happening in all aspects of the project. So now we're just doing the final inspection of the lines, how they brought the lines up from the transformer around the patio, determining that. Would have loved to have done that on the actual inspection. That's typically something we try and do. We look at anything that could possibly go wrong, but just with time, I think we had about 5 or 6 hours out on inspection and diagnosing everything. And it's one thing that we just had to take a chance with. You know, we have a really we have great equipment, great tools, a lot of experience to be able to find that. So we're hoping for a pipe. If there's not a pipe, then we just move on to plan B, which we have plan B and plan C all ready to go. So Josh is going to be walking around and determining where these wires come out of the transformer, get under this patio, and then connect everything from there.
As we were saying earlier, this transformer, when we were evaluating the existing system, we found a dead short in the front yard that was actually smoking, and it wasn't tripping the breakers. So we determined we should replace this transformer with a new one with, I don't know if it's the age of the transformer or a faulty circuit breaker or what it is, but the new Sterling Lighting 600 watt transformer will power this system perfectly with new circuit breakers and much more reliable. And Danny's, he's just removing the old one here, and we're gonna hang the new one in the same spot. So right now Danny is just trimming off the old copper, the old connections, so we can have some fresh copper in our lugs. And also they're a little long for the transformer, so we don't have a lot of slack inside. But he's going to strip back about an inch, 3/4 inch to an inch. And one thing that he's going to do is make sure there's no copper showing underneath the lug, because that's where you can run into some issues if you have open copper in your transformer. So our Sterling Lighting 600-watt transformer is installed, and we replaced the old Vista. And we hooked our lines up, and we started at 18 because this is in the back of the house and our entire system is in the front. So what I'm going to do now is I'm going to take my meter and I'm going to go test the voltage on these 3 lines. And one important thing to keep in mind is you don't want to be over 15 volts at your fixtures. So I'm at 18 right now. I'm expecting to be under 15, but if I'm over, I'll come back up and I'll bump it down. Also, what I'll be doing is I'll be figuring out what these lines are controlling, and I'll mark them with colored tape. And then just in your transformer, you can grab a Sharpie and just write down what is on each line. It'll help you on service calls in the future. But this transformer, brand new, new circuits, won't have any issues like we were having with the old one, and it's much better for a Dayloom system. So right now I'm going to go check the voltage at the lines, and after I get the voltage correct, I'm going to then test the amperage on all the lines and the main amperage on the transformer, make sure nothing's overloaded.
All right, we're at the final phase of the installation. We're checking the voltage at each light. We want to make certain that we're under 15 volts, above 9. Our lights actually like to run at a higher voltage. They run more efficiently that way. We use a boost driver, which just means it's going up to 36 volts versus a lot of the LEDs out there are only using a 3-volt DC driver on it. So there's different ways we can test it. We can test it at the connection. We want to show you a way to test it at the luminaire itself. Now we have all of these. We designed it before we came out, what we wanted the optic at, what we wanted the light level at. But as we open up, we're also going to show you how we can make adjustments on that.
Yeah, so you open the light up. It's just spinning the top and then quarter turn, and then work it off there around the O-rings. Pull your driver out, and you're going to see this white clip. You have 2 contacts on there. That's where you're going to test your voltage. I like to leave the light on. I don't like to unplug it because that will actually change your voltage. So if you want a true voltage, leave that light on.
It gets pretty warm.
It gets warm. We want to set it down. We are right at 15 volts.
Yeah, 15 right at the dot. So that's exactly where we want it. So it's set perfect. You don't always get that lucky. If you wanted to adjust the light level, this is really simple. We use dip switches. Dip switches we feel are a better alternative to many of the things out there. There's cheap RF controls. I don't like potentiometers because it's hard to get the setting perfect. You see it a lot in theatrical lighting actually, using the dip switch method, because then you could set each light level perfectly from one to the next. Once you have the driver put in, the LED fits right on top of it. We designed this a long time ago, 2014, the metal to metal contact. That's what makes all the difference in the world for pulling the heat off. And there's your optic. It's a TIR optic, so it's total internal reflecting. It's the best controlling optic. It fits right in there. If we wanted to change the field angle, we just take out the optic and put a different optic in. So what's nice about this, if we're here and if we were using like traditional drop-ins, if we wanted to change light levels, we would then have to take out that lamp, put a different lamp in, And then what gets challenges down the road is trying to match all of that up. You go 5 years down the road and trying to match up one lamp with the next. But this is a crucial step, testing the voltage at the end of the line to make sure we're perfect on that. That one's all set and ready to go. We'll test a couple more, make sure everything is perfect. Then we'll go back to the transformer, test the amperage, make sure that's in line, mark it all in the transformer, and then we'll be cleaning the fixtures off and going into final stages of sweeping everything down, make it look like we were never here.
Another thing I'd like to point out is the voltage is at 15, which is perfect. We would not have been able to do that with the old transformer. I have this line at 18 volts in this Sterling lighting transformer. So we would be, the max on the old transformer was 15 volts. So we wouldn't be able to power these lights where we would like to with the old transformer.
And you notice that seal, we put a lot to make certain that we're not getting moisture into the light. There's actually, this is a point of entry, so we seal it with a bug plug on the bottom, another sealant in the fixture itself. This, we have 2 gaskets, we use some grease on it, and you just have to lock it in perfect. And so when we're looking to do that, we look at these installations as being permanent installations. So we don't want to cut any corners, we're not taking shortcuts. I'm not going to come out here and adjust each light like every 3 months. I'm typically setting it and getting it right at the nighttime reveal. Prior to that, there might be a couple of tweaks we do when we come and visit at night. But for the most part, once that's set, this tree isn't going to grow that much. Maybe in 5-10 years, I might bump it up one level. But there's usually not a lot of changing that happens if you design your systems right. At the next section of lights, testing this already open, he's putting it on the contacts.
Right at 15.
Wow. We're almost never this good. Usually going back to the transformer to adjust it. Light level is good, we're happy with that. So this light will easily operate with no problems at all at 9-10 volts. It actually can go 16, 17, 18, 19 volts, but we don't recommend that. UL cuts off at 15 at the max voltage according to UL 1838. So we're at 15 volts, we're perfect. Light spread is great. Got our Dayloom sign right behind us. It's always important to put the advertising out, but we'll go to the next section. So we're at final verification on everything and testing on the transformer. We're looking at amperage. Amperage is really important. It's what's going to show us how much energy is on each line. Very often people don't mark the amperage and don't track it. And you could find yourself where maybe your overall amperage on one of the secondary circuits is like 22, 23. So technically it might work, but then like 2 months goes by and all of a sudden it starts tripping. You're just putting a lot of pressure on it. So we want to make sure we overbuild the capacity. We have on this, putting in a 600 watt transformer was larger than we needed to. What Josh is going to do is going to show you how to look at the amperage. Amperage is watts divided by volts. And that's your theoretical, and then this is giving our actual amperage testing. So you need an amperage tester like this. Klein makes a great one. There's a number of great products out there. Pick it up at any electrical store. But Josh, go ahead and show what we're doing here.
Circuit number 1 maxes out at 25 amps, and we are at 10.7, so we are well below there.
And you notice he put that, he's testing the entire circuit, so he put the clamp around both wires. You could test each one individually or just test one. So this next comment is on its own wire.
And this one is at 3.9. So these are far from being maxed out.
And what we like to do is mark the wires now, mark to where they're going to go. So this wire is controlling 5 lights over here. I like to put it in the transformer and have that all set on there. The other thing is you mark the amperage. So if you ever come back for a service call 5 years later, someone could look and see this wire here is controlling 5 lights on the left side of the house, and the amperage was 3.87. If there's a big change, if somebody comes back later and they put the amp meter on it, it's at 12, either there's some type of short happening or somebody added lights to the system. And in our systems, we don't like people adding lights to it because they're not typically verifying any of this, and they overload circuits and overload transformers. The second thing that's an important thing to test is your primary. This transformer can hold 5 amps. So sometimes you could have this running perfect where both sides are under 20, but then you go to test the primary and the primary is over. So Josh, go ahead and show how to do that. You may not have known what that loop was for.
Put it around the photocell loop right there.
And we're at 2.23 as on your total amperage on a 5 amperage transformer. So everything's testing out perfect. We got good voltage to each of the lines. We have good amperage. This is gonna run nice and cool. These transformers, just to let you know, sometimes you get a customer that panics. They're UL tested. Basically every transformer out there is UL tested to run at 193 degrees Fahrenheit, which is hot. I typically like to keep them under like 140, and the way to do that is just overpower, have a bigger transformer and not to put too much on the commons. When you go longer distance, you're putting more pressure on the wire, and that could, more resistance, and that could actually cause it to, the amperage to go up and cause more heat on the transformer. So those are all things we look at on the original design when we're planning everything out. So the last thing we're going to do is we're going through final inspection. We'll write everything down, put everything in our notes. We'll also take photos of everything on the project, do the full cleanup. This transformer is typically a little higher than we had, but there's already drill holes in here, and we also had the outlet that the customer chose to stick with this. So it's a little higher than we typically like it. It does have to be over 12 inches off the ground, but it doesn't have to be 3 feet off the ground. It's easier for technicians to get to it, and so Josh and I go back and forth on that. But typically I'd like to put it down lower in a spot a little further away. So we're going to check all the fixtures. We're going to clean all the lights. I think that's an important aspect, is that first day your customer is really excited about the lighting and we want to present well. Then we're going to do the automation system. So our customer has gone with an automation system. We're using Lutron. Our company uses RAW 2, RAW 3, or Caseta. On this project, we're using Caseta, which is a great program. So that'll plug in right here. We're also going to hook up some of the other lights in the house. There's coach lights out here are going to be hooked up on Caseta. So we'll go through all of that at a little bit later time. But right now, transformer's done. We're going to record everything, and then we're going to go on our cleanup phase. So we'll show you that.